We've covered the basics of our unit vectors, our I, j and k vectors, how they work, what directions they point into, and how we can write vectors in terms of those as part of our working. In this video I'm going to present to you a few questions on this. I want you to read the questions, pause the video, have a crack at them, and then come back and check your solution with the worked answers. Here you go. So first question, express the following vectors in terms of I, j and k. So there you go, you've got three vectors a, b and c. You need to do it for those. The second one is if you've got 2 points, a at -1, 3, 2 and b at 6, 3, -1, express the vector ab in terms of I, j and k. And the last one, I've got a vector p and a vector q. I have to use them to find three properties. First one is p plus 2q. Second one is 3p minus q. And the third one is magnitude of p times the magnitude of q. Pause the video and have a crack. So the first one, express each of these vectors in terms of I, j and k. Now remember when we did the I, j and k and what they were about, they each lined up with one of the axes. They were unit vectors that pointed in each of the directions. The I pointed in the x direction, the j pointed in the y direction, and the k pointed in the z direction. So we've got to use these and see what we've got in this in terms of going in the x, y and z direction, and how we represent this. Now, looking at the A, we remember that we can break this down and say, find that 6 times 1, 0, 0, plus 1 times the 0, 1, 0, and then nothing in the z direction, so plus 0 times the third vector, 0, 0, 1. Remember, this is our I, our j, and our k vector, how we can break them down. What I'm able to do in this is then substitute in the I, j and k for each of these, and I'd have 6 of the i's, so I'd get 6i, plus 1j, so plus j, and then I've got 0 k's, so we don't need to worry about writing it. Now, a quick way of doing this, so you don't have to worry about writing this out every time, is you notice that this is 6i, this is 1j, and this is 0k, so you can actually just distribute it over and write it fairly quickly in terms of that. So I'll show you what I mean with this one. So this one, -10, -1 and 4. So x direction is -10, y direction is -1 and z direction is 4. I can then use it to write these out very quickly because I know I is the x, j is the y and k is the z. As -10i minus j plus 4k. I know that each of these points in the set direction, that's how I'm able to write it out. Now this one here, I've got -1 in the x direction, then nothing in the y and nothing in the z. So my j and my k are going to have nothing. I'm not going anywhere there, so I don't need to worry about that. And this one here is negative in the x direction, so it would just be -i in this case. So there you go, breaking it down. This bit here, if we need that and we just want to make sure we get our heads around it, we can keep using it, but let's try and jump to the very quick way of writing it in one quick step. Second one, so given that A and B are these points, express A to B in terms of I, j and k. Well, the first thing we have to do is get our vector A to B using these 2 points. Once we've got that, we're then able to switch it into this form. Now remember, to get the vector from A to B, we have to do the vector B minus the vector A. Now I've got coordinates for A and a coordinate for B, so remember we could just write these as our vectors. So my A vector is going to be given is -1, 3, 2, and my b vector is just 6, 3, -1. Remember, these vectors are the relationship between the point here and the origin, so the journey from the origin to that point, and it's just essentially given by the coordinate written as a column vector. So b minus a gives me 6, 3, -1, take away the -1, 3, 2. So 6 take away -1 gives me 7, 3 minus 3 gives me 0, and then -1 take away 2 gives me -3. So my vector A to B is 7, 0, -3. What I now want to do is write A to B in terms of I, j and k. Now remember, the I is the x, the j is the y, and the k is the z, so I can just jump straight in and write it out. I've got 7 in the x direction, so that's 7i. I've got 0 in the y direction, so there's no j's, so we don't even need to worry about writing that. And then I've got -3 in the z direction, so it's then going to be -3k. So there you go, I've got my vector a to b in terms of I, j and k. Yeah, there's no j there, but that's fine because it's 0 in that direction. We don't need to worry about writing it. Third question was I had these two vectors here and I had to find these properties with them. So I had to find p plus 2q, 3p minus q, and then magnitude of p times the magnitude of q. Now, when we're doing vector operations when it was column vectors, we matched up the x, the y, and the z's, and we did the operations between them. I.e., if it was plus, it would be the x for the one plus the x for the second, y for the first plus y for the second, and z for the first plus z for the second. In this case, it's still the same. The only thing we have to make sure we do is any scalar multiple first, and then we add together the i's, the j's, and the k's, we match them up with their respective partners. So in this case, p plus 2q would be my p vector, so 2i minus 3j plus k. It would then be plus 2 of my q vector, so 2 bracket negative j plus 3k. Now at this point, we get rid of any multiples, i.e. we do any scalar multiples of the vector, and then we combine them. So my first one stays as 2i minus 3j plus k, and I'm multiplying by 2 for this one here, so I've then got plus, keep it in the bracket, negative 2j plus 6k. Now it's a case of going through and matching up the different components with each other and adding them. So I've got 2i here, and I add the I component from here, well there's nothing, so I'm just left with 2i. I've then got negative 3j plus the negative 2j, so negative 3 plus negative 2 is negative 3 take away 2, so I've got minus 5j. Last one, I've then got plus k here, plus 6k, so I've then got plus 7k. So there you go, I've combined them together. It's like that. Write them out, scalar multiples, combine the terms. So 3p minus q is the same sort of thing. So it's 3 times the p vector, so 2i minus 3j plus k. It's then minus the q vector, so take away the q vector, which is negative j plus 3k. Again, same sort of idea. Scalar multiples first, then we get rid of any of the respective components by combining them together. Scalar multiple of this one gives me 6i minus 9j plus 3k. Let's take away, this one's got no scalar multiple, so we leave it as it is, negative j plus 3k. Now again, we combine the i's, the j's, and the k's together with the respective partners. Look at the i's, well there's only an I in this direction, so it's 6i. The j direction, we've got negative 9j minus minus j, so minus minus becomes a plus, so it's negative 9 plus one of them, gives me negative 8j. I've then got 3k minus 3k, that gives me nothing. So there you go, the vector we're left with for 3p minus q is 6i minus 8j. The last one is the magnitude of p times the magnitude of q. Now to do this one, we have to calculate the magnitudes first. Remember, that doesn't change. The magnitudes is still the square root of the x squared plus the y squared plus the z squared components. So the magnitude of p is given by the square root x squared plus the y squared plus the z squared of 2 squared plus the negative 3 squared plus 1 squared. So 2 squared is 4, negative 3 squared is 9, 1 squared is 1, so it's 4 plus 9 plus 1, so it's the square root of 14. The magnitude of q, same sort of idea, you just go through each of the components. No k's, you've then got negative 1 squared for the j, plus 3 squared for the k. Negative 1 squared is 1, 3 squared is 9, so that's equal to the square root of 10. So then magnitude of p times magnitude of q, we just multiply the two of those together. So we get root 14 times root 10. That then, root 14 times the root 10 gives me square root of 140. If we're asked to leave it as a third, we have to simplify as much as possible. So that ends up giving me 2 root 35. However, it could also ask us for a value of it to maybe 1 decimal place. If it does that, we get 11.8 to 1 decimal place for this one. So there you go, 2 different variations of the answer. It all depends on the paper and how it asks you for the solution. So we have to bear all of these different steps in mind and all of these different skills. So being able to write the vectors in this form, being able to go back, being able to use them in calculations, and how we work them together.